Welcome back to Workplace 30. We're starting on 5.2, which is titled Quadrilaterals. And you can start by reading Math on the Job on page 191. And then we're going to identify all of the quadrilaterals in this image. So, Brianna, do you know one quadrilateral you see here? One kind. Okay, the window like this one? What shape does that make? Rectangle, good. So there's rectangles. Also, these here between these bars would be rectangles. And yeah, all those windows would be rectangles. There is no door on here. Right here? Sorry, and the door would also be a rectangle. Okay, there's another type of quadrilateral. What kind is that? And the next shape there is a trapezoid. So a trapezoid is when you have two parallel sides, but then two that aren't parallel. What do they all have in common? They're all part of the same house. More specific to the shape. Okay. What about the number of sides? Good. So a quadrilateral means that it has 4 sides. So that's something that they all have in common. Next, we're going to read the Explore the Math on page 191, and please fill in the following definition. All right, so you can check to make sure your definitions are as listed here. Also, please write down the properties of a quadrilateral. All right, so discuss the ideas, page 192. We are building a patio that is supposed to be the shape of a square. So we want to consider the measures of the corner angles. So all of them will be 90 degrees. Parallel lines. So opposite sides are parallel in a square. This is the symbol for parallel, and you can use this anytime instead of the word parallel. Also, the lengths of the diagonals, they are congruent. So if you'd measure from B to D and from C to A, those would be the exact same distance. This is our symbol for congruent. We always use congruent with shapes because shapes do not have an actual number value to them. So if we're talking about lines, we can see the lines are congruent. Okay, number 2, then she makes a mistake and she actually has CD go too far. So then, what type of shape has she created? A trapezoid. Good. Actually, to be more specific, it's a right trapezoid because these two angles are at 90 degrees. So it's a right trapezoid. B. Which measurement will identify that she has made a mistake? So how can she tell she made a mistake? So to figure out B, let's consider our 3 properties of squares that we just listed. So let's start with the angles. We can tell right away that the measure here of angle C is not 90 degrees. So that takes off the first criteria. The next one is that all opposite sides are equal. But here we can see that, are parallel. But CB and DA are not parallel. So that does not work. Also, if you go and measure the diagonals, they are not congruent. Question 3. Pauline locates a new corner E by measuring diagonal DE equal to diagonal AC. So now we have this diagonal and this diagonal are equal. She knows that. Explain why she has not yet corrected her mistake in the layout. So what she actually did here is by moving point E, she made this shape side CD and side AB, she made longer than the other 2 side lengths. So this is actually a rectangle. Question number 4. In part 2, she created a right trapezoid. An isosceles trapezoid is another kind of special trapezoid. Examine the following diagrams. What properties must these trapezoids have? Consider corner angles, parallel lines, and the lengths of diagonals. Okay, so let's start by considering the corner angles. Here we have 2 90-degree angles, so that makes it a right trapezoid. But here we have 2 sets of congruent angles, so that makes it isosceles. Parallel lines both have 1 set of parallel lines. And if you consider the diagonals of the right trapezoid are not congruent, but the diagonals of the isosceles trapezoid are. So where are trapezoids used? We have one right here in our classroom in this one table. It is an isosceles trapezoid. Here's another one. What type of trapezoid is this? It's isosceles. Good. Because these angles are the same and these angles are the same, and we have one set of parallel lines. Good. Example 1, page 193. We're building a water trough for a cattle farm. We want to use a ruler and a protractor to measure the angles and diagonals of the indicated face of the trough. What shape is it? Okay, so I'm going to start by measuring angle A. So when you drag your protractor on it, you want to make sure the center point here of your protractor is right on the vertex of the shape. Okay, then you will, it's hard to do on the smartboard without, because it's so small. There we go, make it a little bit bigger. Okay, then we're going to move our angle, and you're going to look to where it meets that line. So it's right about there at 77 degrees about. If I click this, it'll tell me exactly what it is. Yes, 77. So there I have a 77-degree angle right on that point. So you're going to do that for all of your angles, and then also measure the diagonals. Go ahead. So these are the angles that you should have found. Keep in mind that whenever you have two parallel lines cut by a transversal, their same side interior angles have to add up to 180 degrees. So 77 and 103 have to add up to 180 degrees. Make sure yours do. Okay, then we're going to find the volume of this trough. So volume, we have a formula for that, is the area of the base times the height. So the base is this shape that we're working with here. So it's a trapezoid. So to calculate the area of a trapezoid, it is 1/2 times your top plus your bottom. So the top of your trapezoid plus the bottom length of your trapezoid times the height. So here we get 1/2 times 0.55 plus 0.4, all multiplied by your height, which is 0.3. So your volume is 0.1425 meters cubed. Remember, cubed is for volume, squared is for area. We want to actually figure out how many liters, though. So this is how many meters cubed we have. 1 meter cubed equals 1,000 liters. So how can we set this up? Cross multiplication, so proportional reasoning. Great. So we want to figure out how many liters 0.1425 meters cubed is. And we know that 1,000 liters is the same as 1 meter cubed. So when you cross multiply, you'll find that X is 142.5 liters. Okay, so we're going to consider parallelograms, rhombuses, and kites. First, we want to have a look at which sides are the same length. So let's have a look at a parallelogram. Which sides are the same length? Okay, the opposite ones are the same length. So opposites are congruent. How about with the rhombus? Which sides here are the same length? Okay, all sides are the same length. So all sides are congruent. And with the kite, we have two that are congruent, and then the bottom two are also congruent. So here we'd have, and this is supposed to be a P. So here we'd have SP is congruent to PQ, and SR is congruent to RQ. Okay, next point. Which sides are parallel? So if we look at the parallelogram, opposite sides are parallel. So opposites are parallel. Same with this one, rhombus. Opposites are also parallel. And with the kite, none of them are parallel. Okay, then the next, oh, I just moved my sheet there. The next one, which corner angles are equal? So for the parallelogram, we have opposite angles, or ones across from each other, are congruent. So we have A and C, and angle B and angle D. So angle D is congruent to angle B, and angle A is congruent to angle C. Same with the rhombus. The ones across from each other are congruent. So angle Z is congruent to angle X, and angle W is congruent to angle Y. And with the kite, we have just these two are congruent, not R and P. So angle S is congruent to angle Q. Okay, then last one, sorry, not last one, lengths of diagonals. So if we look at our parallelogram, the lengths of the diagonals are not the same. If we look at the rhombus, again, they're not the same. And if we look at the kite, again, our diagonals are not congruent. Then let's have a look at the angles. So here, the parallelogram, they do not intersect at any special angles. With the rhombus, diagonals are perpendicular, which means they're at 90 degrees. So diagonals are perpendicular. This means 90-degree angles. Same with the kite. The diagonals are perpendicular. So those are properties of parallelograms, rhombuses, and kites. Question number 2. Patrick uses a platform wheelchair lift to bypass the front steps of his house. All lift struts are the same length and are joined at the midpoints and endpoints. So if each one of these is the same length and they're joined at the midpoints, okay, that makes each one of these the same lengths also. So right away you see same side lengths. What shape do you think of? Okay, a square. Now a square needs to have 90-degree angles. So this is not a square, but it does fit one of these. It's a rhombus, good. So we know that this is actually a type of parallelogram also, because opposite sides here are parallel, if you'd actually go and measure them. But since all these sides are the same, that makes it a rhombus. How do you know that this platform here is always horizontal with the ground? Okay, they lift at the same angles, so we actually have here a bunch of parallel lines, right? So we know that if I would say extend this line here, this line and this line are called alternate interior, and they're always going to be the same angle. So that'll always mean our two are horizontal because they're parallel. Then you just have an assignment on page 198, number 1 to 6.